Halo, Dokter.
Yeah, please share your presentation slides.
Can you hear me clearly? This.
Yes, I can hear you.
Okay, can I start?
Wait a while. I can't see your face. Could you please put on your camera?
Okay, nothing. I'll have it go.
Yes, and your slide is not here yet. Can everyone see this slide?
Yes, I can see the slides.
Yes,
Okay.
sir. Me too.
All right. So if everyone can see the slide, well, let me introduce. This is the session of Viva Voce for mixed mode student. The student who is going to present is Mr. Gao Zheyi. And the supervisor of the student is Associate Professor Dr. Ko Boon Yin. The internal examiner for this session is Dr. Chu Ai Lan from Inform, and the external examiner is Assistant Professor Dr. Gita Sagal from AIMS. So I'm the chairperson of this session. So if everyone is ready, then we can start. Okay.
Okay.
All right. So please go ahead, Gao Zheyi.
Okay, thank you, Doctor. Good morning, distinguished professor and committee members. My name is Gao Zeyu, and my supervisor is Dr. Hu. The topic of my thesis is the growth inhibitory effect of costin on cancer cell lines. Sorry. Sorry, I have some. Okay. Let's start with the background. Cancer has become increasingly serious issue in today's world, which is why this research is important. The World Health Organization says that there will be an estimated 20 million new cases of cancer and 9.7 million deaths in 2024. Globally, about 1 in 5 people will develop cancer in their lifetime. About 1 in 9 men and 1 in 12 women will die from cancer. Cancer has become the second leading cause of death worldwide, especially in economically underdeveloped areas. These two figures show the incidence and the mortality of cancer worldwide and their relationship with gender. To address this, nature products like costin have gained attention. Costin is a plant flavonoid belonging to flavonoid group of polyphenols and has strong anti-cancer properties. Costin can also effectively inhibit the growth and the proliferation of virus cancers and reduce cell viability, autograft, autophagy, or promote apoptosis by regulating signaling pathways. However, to fully understand its potential, we need powerful tools. This is why we study utilize the NCS60 panel and the GEO database for high throughput screening. NCS60 is an in vitro drug discovery platform representing 9 tumor types, which is used to continuously screen potential advanced drugs and study drug responses. The gene expression omnibus GEO stores the genetic data of the target cell lines we need. Now, I will tell what's the problem we want to study. I found a large number of epidemiological studies highlighting the potential of costin to reduce cancer cell viability, growth, and proliferation. However, only a few cancers were focused on. More human cancer cell lines that might respond positively to costin treatment have yet to be elucidated. As such, our preliminary study aims to investigate the effect on 60 different human tumor types, human tumor cell lines using the information in NCSK databases to identify the human tumor cell lines, to identify and characterize different cells growth inhibitory effects upon costin treatment. The effect of costin in the NCSK cancer cell line panel is well documented but not well studied yet. Based on the idea, I formulated special research questions and hypotheses. Can the NCSK panel of cancer cell lines provide enough information for the selection of the best cell lines upon costin treatment? What is the gene expression of selected cell lines upon costin treatment? What are the levels of the growth inhibitory effect of costin-rich subtraction of red onion peel ethanolic crude extract on the selected cancer cell line compared to pure costin? What are the levels of Ki67, cis-NA, and PGP gene expression in extract on the selected cancer cell line compared to pure costin? And my study hypothesized a new approach to identify a cell line from the NCSK panel of cancer cell lines that exhibited the best effect upon costin treatment. The gene expression profiles associated with the growth inhibitory effect of costin on the cell lines could then be analyzed based on the GEO repository. Compared with pure costin, the growth inhibitory effects and some gene expressions of the extract can also provide a fresh perspective on cancer research. My research main objective is to comprehensively identify the growth inhibitory effects and its related genes expression of costin on cancer cell lines. To achieve this, I have set 3 specific objectives. To identify the cancer cell lines that shows the best growth inhibitory effect upon costim treatment in NCI-60 cancer cell line panel to analyze the gene expression associated with the growth inhibitory effect of the selected cell line in the GEO repository to investigate the growth inhibitory effect and a few gene expressions upon the treatment with the costim-rich subtraction of rhodanium pure ethanolic crude extract compared to pure costim in the selected cell line by cell-based proliferation assay. Now let's move to the methodology. To achieve all the objectives mentioned just now, I first brought the NCI and the GEO. The NCI-60 database was first accessed through the NCI-DTP to select cell lines showing effectiveness upon constitution. High-throughput functional genomic data of selected cell lines was started through the GEO database or NCBI to annotate gene identity dataset title, link to about information, and graph describing the expression level and record of the gene in each sample in the dataset were included and studied. After that, the selected cell lines will be cultured and treated. The cell will be treated with a costim-rich subtraction of rhodanium pure ethanolic crude extract, and for comparison, pure costim will also be used to treat cell. After treatment, the treated cell will be subjected to anti-proliferation assay like LDH. The cell morphology after the treatment will also be monitored under a microscope. The treated cells will also undergo total RNA extraction and the cDNA synthesis. The cDNAs will be used to detect the identified gene from GEO by semi-quantitative PCR. Finally, the GradPad software will be used to make all the plots and statistical calculations. Now we're moving the results. This is the NCI-60 results. This figure shows the dose response curves of costim against the panel of NCI-60 cell lines. Most of the cell lines display the growth inhibition effect upon costim treatment. I also managed to select a few cell lines that display the promising growth inhibition upon costim treatment. As shown in this figure, the cell growth level ranged from 35.1% to 58.4%. Most notably, K562 showed the distinctive response at this dose. This significant growth interference made it ideal candidate for the characterization of its resistance mechanism. Based on the GI50 value among the selected cell lines, only CCRF cell is sensitive, but K562, NCIH522, and A498 are resistant to the costim treatment. SF 531 and U251 showed no effect on the treatment, and no effect on the treatment, and no information was found on MDA-MB for 35 and HS cell lines. Based on those screening results, I selected the K52 as the model for further investigation. Next, we look at the GEO results. Based on a dataset submitted to the GEO database for the project identity entitled the costing effect on gene expression in HepG2 hepatocellular cancer cells. The dataset was divided into two groups, one treated with costing and the other serving as control group. Treatments were applied for 2, 4, 12, and 24 hours. The same phenomenon of differentially expressed genes was observed in the selected genes in the heat map. The figure variously presents the difference in gene expression, specifically the observance levels of three selected genes, Ki67, PCN, and PGP. Under these conditions, Dr. C was used to quantify the magnitude of gene expression changes between treatment and control conditions, and show the various gene expression levels over treatment period. In that case, the mRNA expression of Ki67, PCN, and PGP genes is not statistically significant under these treatment conditions for this set. Now, for the most important part, the lab validation. The cytotoxic effects of costing and subtraction of iranium pure ethanolic extract in K562 and HepG2 cells. As shown in figures, little or no detectable LDH was released from K562 cells after costing treatment at various concentrations for 24 hours. All curves were indicated below the y-axis 0 line. Similarly, K562 cells treated with the subtraction of radium pure ethanolic extract for 2 hours and 4 hours also showed little or no detectable LDH release. The optimal cytotoxic effect was only observed after 12 hours of subtraction treatment with EC50s of approximately 34.4 microgram per ml and 7.5 per microgram per ml at 12 hours and 24 hours respectively, whereby the idle dose response curves of subtraction showed higher potency at 24 hours than at 12 hours of treatment. On the other hand, HepG2 cells treated with costing and the radium pure ethanolic extract subtraction showed little or no detectable LDH release. The curves of ideal dose response were only observed at 12 hours and 24 hours of subtraction treatment. The optimal cytotoxic effect of subtraction treatment was observed to yield EC50s of approximately 9 microgram per ml and 24.5 microgram per ml at 12 and 24 hours, respectively. This part of the study indicates that both cell lines are sensitive to treatment with a cost-enriched compound, despite the subtraction's effect being more potent in K562 cells than in HepG2 cells. Then we use the PCR to investigate the molecular mechanism behind cell death. From mRNA expression of KX67, PCN, and PGP, PCR analysis didn't detect any significant effects of KX67 in control of subfraction-treated K562 cells. However, PCR analysis detected a significant reduction in pCNA mRNA expression in subfraction-treated cells after 24 hours compared with control K562 cells. The phenomenon is consistent with the growth inhibition observed in K562 cells using the LDH assay after subfraction treatment. Similarly, PGP, a gene associated with drug resistance, also showed reduced gene expression in the subfraction-treated K562 cells calculated at 24 hours of treatment. This is the GAPG2 this brings us to the calculation. In summary, the data from this study indicated that costin and its subfraction exhibited significant growth inhibitory activity against specific cancer cell lines. Our molecular finding provided strong mechanistic evidence that the subfraction exhibited its superior anti-cancer effects by simultaneously downregulation pCNA and K proliferation markers. This supported the view that the natural costin complex might exhibit a more significant pleiotropic therapeutic potential than the signaling signal compound. My future work will further demonstrate the growth inhibitory and cell cycle effects of the costin-rich subfraction in K562 cells using assays such as CCK8 and anything with steroid may also be used to assess the subtraction effects on K562 cell structure and the microenvironment. This is my reference. And thank you very much for attention, and we're happy to answer questions. Thank you.
Okay, thank you, Mr. Carl. Oh, now are you okay?
Okay.
All right. All right. Now I would like to invite Dr. Geeta to comment or ask the questions. Please go ahead, Dr. Geeta.
Okay, Dr. Ang, thank you. Okay, Mr. Goh, thank you for your presentation. have went through your thesis as well. So I will start with my general comments. Then all the comments and everything I'll share with your supervisor, so you can do some revision on your required area. Okay, first of all, okay, the title was very short and precise, which is aligned with your abstract, but then for your abstract, I think you have used a translator, so kindly check with the your institution for the Bahasa Malaysia abstract. And beside the language and the content, there is the format is totally different, because I think USM, it has, or Inform, it has own format of a thesis write-up. So the first I will comment on your thesis, that uh, your abstract for Bahasa Malaysia and Bahasa Inggris, you didn't follow the format. So please refer to the format and follow on it. So that's the first part. So you have to rechange on your formatting all your thesis. Okay, that would be the first. And the next, I'll go on the in your introduction and literature review, uh, because you were, uh, I mean, uh, your topic is related on your growth inhibitory effects, but then the literature review as well, the introductions has a broader pharmacological properties, like you were discussing more details on the antioxidant and antimicrobial, but then there's a lack information on the gene expression changes, how it emphasizes on the growth inhibition on the selected strain. So you need to add on information on that as well. It's like kind of a lack of flow and information that you have made it in your literature review and also the introduction. So could see that there has some lagging of the flow. Okay, because while you're presenting it slide one by one, you are going through it, but when we are reading it, we could see that there's some lack of a connection in between each of the topics as well as with the content. Okay, so that were the first thing you have need to improvise on it. The second one, there's a redundancy of a repeating content. That means when you are talking about any of the explanation, the same points are redundant in the few other paragraph. So it's like a try to avoid that and improvise your grammatical mistake as well. Okay, and then the after this, okay, I would like to move on it, because this is part that you need to edit on your literature review, because the content are less. You are not explaining on the required content that your topic. Okay, so that's the main part. So when we move on to your methodology, okay, for methodology 3.4, and another one more thing, because if you see the abbreviation, so I think in the text you have used a lot, but then the number of the abbreviation that you have highlighted in your thesis are very few. It's not even one page, I think. So try to check back again. Wherever you are using the abbreviation, you have to list it out. So that's why you have a list of abbreviation. So recheck on that as well. So now in the methodology for 3.4, okay, at the 3.4 method, you never specifically mention about the concentration ranges that you used for the LDH essay, and also the time points. It's I could see that from your method, because I'm also having a thesis over here. Okay, you have mentioned it generally, like from where you have taken up your method, but then the citations are missing. Like for example, for page 13 in your thesis, on your page 13, that if you see for the 3.4 cell cytotoxicity test by the LH assay, okay, from where you took this method, there's no citation. That means the method you are referring to, where the another manuscript you didn't highlight it. So most of the method has a lack of a citation, so try to add on it. And in between, in the same page, page 13, you have mentioned to control, low control, high control. What is low control? What is high control?
For the LDH,
Yes.
oh, let me explain. Sorry. Actually,
Sorry, can I interrupt? Zoe, can you share your thesis? Maybe it's easier to discuss based on the thesis.
I'm
Yes,
showing
ma'am.
you. No.
Thesis, not your presentation slide. Your thesis, your soft copy PDF file.
Okay.
You just replace your presentation with your thesis.
So I need to show my thesis. Yeah.
Yes.
Okay. Because I use Chinese the word, so it may be some difference.
Okay, you move to your methodology. For me, the page number is 13.
Methodology. Th 13.
Yes. 13, 1-3. After the preparation of your stock solution at page 12. So 3.4 is your cell cytotoxicity test. Because I'm referring with the this is shared with me. 3.4. 3.4.
Okay.
Yes. Okay. So here, after the first para, the second, you have written here that two controls included: low control, high control. What is explaining over here? What is mean by here the low control, high control?
The low control is the natural release. The cell, the LDH natural release from the cell, and the high control is all the cell will be like this, and they release all the LDH from the cell. Yeah, because you know the LDH is enzyme.
The term that you're using it low and high, is it correct? Because normally either when we talk about discussing about the controls, it may referring to negative control, positive control, or if you're using any standard. Low and high, are you quantifying it? Anything on this?
Sorry, I don't understand this question.
No, my question is, when you're mentioning as low control and high control, are you quantify it to give the term? Low and high, in what term you are referring here?
I think the low control is the y-axis zero line. This is the low control, and in this figure, the 100%, the y-axis 100%. This is the high control, and because this LDH results, its formula is use the simple mice the culture, and they will
Okay. So
sorry, Dr. Gita, maybe I interrupt a bit here.
Sure,
Zoe, I
doctor.
have this. Yeah, I have the same question as Dr. Gita. Maybe I put it this way: why do you have to do LDH here? Why do you put LDH here, high and low? What is the significance, or why should you?
Well, sorry, why should we choose the LDH assay? And
Yes. Why? What is the reason? Why do you have to study LDH low and high? What is the role of LDH here?
I don't know. You want to me answer the why I choose the LDH or why I use the low and high control? This,
Yes.
uh, I use the LDH assay. It's mainly because the difference in detection mechanism and specifically the LDH is stable enzyme in the cells, and it only released into the culture media when the cell death or the cell membrane will damage. Yeah, it is damaged. So the LDH can detect directly show the cytotoxicity, and the assay like MTT and like CCK8, they actually measure the viability. It's not the toxicity. But so the LDH will more directly to explain the cell death. And another answer, another reason is protein is a polyphenol, so it have strong antioxidant and reducing properties. So it may be when the when we detect the MTT or the CCK8, it may be have some interference. Yeah, that's all. And of course, this LDH is more easier to MTT. Maybe we will do 3 days, and if we if we must have the long experimental time, we may have the more mistake.
So, your conclusion from what Dr. Lim asked is actually its LDH is easier compared to MTT assay.
Yeah, of course, yeah, because it's Kate.
Okay. Have you done validation to say this LDH assay is easier compared to the other test?
What do you mean? It's validation of the LDH?
Before directly you are working with your cancer cell lines, most of the time when you are developing a method or you want to follow something, you need to do the validation, right? For the particular method that you are following. by using normal cell lines as a control, then you will know that how you are performing it. Then you will be moving on with your cancer cells. Have you done on that?
Yeah, this LDH as a result is be normalized. Yeah.
Hmm. Dr. Chu? Okay, I think I'll pass this, the question to Dr. Chu. Then I will move on to my next point,
No,
so that
it's okay. You proceed to the guitar.
okay,
I'm okay.
thank
proceed.
you, Dr. Chu. And for your next method, that when you are doing, I think 3.5, yes, for the PCR cycling, you have didn't mention about the specific cycling conditions, like annealing temperature, how many cycle numbers. You have mentioned about the primers, I think in the page, it's on a page 14. So sorry, 14, 15, you have a given address description about all your PCR, RNA synthesis and everything, but then the conditions are missing. So maybe you need to edit that in your 3.53, what the condition you use for PCR procedures. And as well, there's a no the how you quantify the bed or the your results, which are you used any softwares to take the picture to analyze the band, or you want to, because in your results I think you have shown about the expression of the gene. So all these are missing in your methodology. Okay. And then 3.6, page number 16, you have it is very general statistical analysis performed by using, okay, GraphPad. But then are you used, because you were talking about the significant differences, but there's no description that you use ANOVA, uh, and then so this is also, I find that some informations are missing over here. Okay, so you need to have a complete clear information you need to add it on, because it's like a very vague when you are writing about the methods, because your methods, when you are presenting it, it should be reproducible and helpful for others as well, right? So that, let's say, when I want to use your method to carry out the same method for other cancer cells, so it should be reproducible. So this, like a, do go through on your method, add the citation or reference from where you have chosen your method. If there's a modification, clearly mention the modification, what changes you have done. Okay, so that will be giving a precise methods on this. So then I would like to move on to the results part. Okay, for the results, okay, when see your graph, okay, sorry, 1 second.
Well,
Okay, for your results, if you because in your thesis that you submitted for figure 4.1, you have included all the figure in one. I think there's a 9 figure, and how I enlarge also, for me it's quite blur, uh, because we need to clearly to see the results, and then um, it quite blur. So I would request you to separate the 9 figures that you add in your page, I think page number 18. Okay, page 18, to please make sure that either you separate it into at least two or three, if let's say they are in the same timeline or same cell lines. For me it's very very blur, so I couldn't see the figure as well. Even now when you are showing in your presentation, I'm zooming up to 250 percentage, also for me it's very blur. And from what you are sharing in your results, there is like a minus value in the figure you are showing it. So why it goes up to the minus value, and there's any reason why you have put everything together in one?
Uh, put everything in one. What is put everything in one?
Yes, we have to analyze your results, right? When you
Ah,
are showing it, there's a positive or report or something on your results to show is this valid. But then when you are clumping all in one figure, we really can't see that value. It's like it's like very blur. Then how we know that what
ah.
is your outcomes?
You you mean you mean why I use this figure? Uh,
Okay, explain all this nine. Can you, what is the first figure, what is the second figure, what is the third figure? Because I couldn't see anything from there.
this is one. This is two. And the figure has the number.
No, my question is, what is the purpose of figure one?
Yeah, figure one. Oh, it's, uh, figure one is just show the because the my all of the GEO results is from this compound, this NSA 9219. My all of drugs is from this SAB compound. And they get this result. So I put this one on here. It to show costing is costing have the effect for many cells, and so we can find some cells yet somebody not studied, we can study it.
So out of these nine, which one is the best?
This is also the cytotoxic cytotoxicity figure. So the more the more low the cell line is show the costing is more sensitive. Cell line is more sensitive. Costing is more stronger. The more lower.
So in the nine, which one's the best?
This one,
The lower one that you are showing, is it the number nine?
yeah, the lower one.
So you
The
have to put that as a specifically, and then you have to give the caption, right, to mention that this is actually the best providing the activity, right or not?
I can put but because this just uh like it's not very important, so just to show here.
Mr. Go, it's actually you have spent a lot of time and you have all the results. So this is the platform there you have to show the results one by one so that the evaluators will have the idea that your work is worth, and then you are giving good results, right or not? When you're
Okay.
combining everything and then now you're telling that this is not important, so why you have done all this? So what I'm trying to say here, there's maybe, I mean, not maybe, you need to rearrange all these nine figures and you have to give the captions So let's say in the 9, because I'm not really clear about all this 9, what is their function, what is the role, are they in a different concentrations? So you have to separate it nicely. You have to refer with your supervisor, follow their instruction. You have to separate it, give a proper clear caption, and along with this, because you have mentioned that you use GraphPad of a statistical analysis, right? So in this graph you have to add the error bar. So that means how the standard deviation, are you using standard error bar or SD? You have to add that as well, and then you have to show the in your graph, because that will becomes under the statistical. Okay, because from what I try to enlarge here and see, I only can see a dot and with a different line and colors, but there's no standard bars. So if let's say in all this 9 you have done the replicate and you have done this analysis, you have to do I mean when you find the average, that you will be by mean will be getting the ST or SEM, right? So add the standard error bar, so that will shows that how significant your results as well. Okay, so that's one where you have to do with your figure 4.1. You need to do the changes, and after that, can you move to your figure 4. The next results? Okay, I think it's, let me check with my page also. Okay, yeah, the same thing, because you have highlighted of figure 4.2. You have mentioned that that is a one dose growth inhibition. Okay, then you have chosen the 8 cell lines are notable growth inhibition selected for further analysis. Okay, so you have highlighted here.
Yeah.
Okay, so all these 8 cell lines you have used for the following test, is it?
Oh yeah, this 8 cell lines will be used for this for the GFT. Second, the screening.
For the following screening. Okay.
Yeah.
But then when I see even your 4.6, I can only can see with the K562 and Hep G2.
4.6.
In your results 4.6, when you're done with the LDH cytotoxicity assay, right?
I don't have 4.6 results of
Figure 4.6,
figure.
page 26 in your thesis. I think you have mentioned about the growth inhibitory effect for K562 and Hep G2 cells by LDH.
Yeah.
Here you only use 2 cell lines out of 8. Am I correct? Am I get the point?
So you mean why I use the K562 cells and HepG2 cells to test the LDH assay?
Yes, because from your write-up, what I read that you have selected the 8, it shows that the results from the figure 4.2. So then after that, when I go with the following results, for your part, even 4.2, you have mentioned about the FGDO gene expression profile, and then the title is actually HepG2, but then inside you have a discuss about the K562 cells as well. So it's like a, do you understand that what you are saying it, but it's not presented in the thesis results? So it's like quite confusing, and like, I mean, directly I could see that in your 4.3, the figure 4.6 is only I mean presenting for K562 and Hep G2, but the remaining 6.
I explain one by one. One step. from the my first step is from the NCI60 to choose the to choose one cell line to further to do the further investigation. So I choose this choose 8 cell lines from the one dose response. And why I choose this? Because it's sensitive. And I choose this and next from the GFT from the 8 cell line, we second screening the 5 cell lines. And we can use this picture. The left is resistant, the right is sensitive. And we see the number. We all know the log is the log picture is the value, the log value more big, and the reality value the reality value is more smaller. So we choose the resistance, and this is finally a screening. K562 is have a very 4.2 is lower than like the CCRF CEM 4.5 and this 4.3. Yeah, is lower than this, and because it's negative value, so because it's negative value, so it is biggest resistance for the GICT value. And now we have a question: why the one dose is sensitive and the second screening is resistant? Because we need we must use cell lines that it can respond to the protein, and the K562 is more sensitive because only cell line is sensitive is can get obviously you can get obvious 这个sorry yeah, it can get obvious results because we need do the anti-proliferation assay and PCR. So we get those conditions. We finally choose the K56 K57 56 tool, this cell line. Actually, these three is all can be chosen, but this cell is easy to for my teacher. This cell is easy to get and easy to culture. And next, this is why we use the GGO to select the HepG2 because we can because I see the from this this strategy to raw data from this title is not very good, but we also can get some up regulation and down regulation trend from the raw data. So I can, and this title is this article is good, and I can I can get some raw data from it. Now now is which gene, because the raw data have a lot of gene, which gene we need to choose to do the further investigate to do the PCR.
Okay, okay, Mr. Go, understood. Because you are trying to give the flow. Okay, my point is, when you are explaining it, you have the point, but then when we are reading it, it should have the connection. So it's missing in your thesis. So that's why there's a lot of questions arises when we read, because I don't know how, I mean, what you have done, what is your understanding, right? But your write-up must be clear so that I will understand, and I would be happy to see that you have a lot of data. You have done a lot of molecular work on it, which is like a really a good work on it. But then the way of your presenting it, putting it in your thesis is very important, so that we will be understand your value, your time, that effort you have done. So the write up in your because this is when it comes to the results. That's why I say that there's a no connection. When I move on to your discussion, if you see, okay, this is like a when for your discussion, I would say that you have to rewrite, you have to redo your discussion, because a lot of informations are lacking. You are explaining to me the informations and everything, but the supporting data that you need to write in your discussion, it need to be fulfilled. It's not like a kind of a summary. I would say that your discussion is just like 1-2 page. You have done so much of your results. It's just in it's a kind of a conclusion. That's not a discussion, because when I refer your discussion, it's like clueless. So that's why I have to ask so many questions. When every results you have presented, you need to explain, you need to say support your data. So from the figure 1, where you have done for out of 9 different cells of those dependents, the content and their outcomes, you have to explain, because you need to mention that why it is so. So the same similar goes to for the other results, 4.2, 4.3, 4.6, so continuously. So you need to rewrite on your discussion, because it's for me, if you ask me, it's a conclusion, it's not a discussion. So because my point is, I thought like the discussion is missing, and you are just wrapping up with that. Okay, so and for your discussion, that would one another one more is like your supporting finding, even in that 2 page of your discussion, you have very old references like 2000 up to 2010, because when you are presenting scientific data, you need to have the latest reference. It should be less than 10 years. So that means you can access, you may have a 1 or 2, but not 80%. So you need to change, get the information articles like recent publication on the quercetin, and also with the onion peel, with the particular cell lines that you have used, and also the molecular expression gene. So you have to check on that as well. So that is also very important, that you need to change all the individual of the reference. You need to go with the citation of the updated. Okay, so in I mean in because I think that times is run up, because I need to pass to Dr. Chu also. So my I will just conclude with the mine is actually your discussion need to rewrite back again with the latest and supportive findings. Okay, and then explain with your results with the proper captions. And for your references, it's a I mean, you never include some references years are missing, and there's no uniformity, and there's a lot of reference missings. That means in your literature review, in your introduction, you have cited the name, but it's not in the list. So all the missing references, the details I will be shared with your supervisor. So try to have a uniformity. So that means if you are using APA format or Harvard format, so try to follow the format, or you can refer back to institution. They will be having a guideline to write the reference. So please follow the references as well. Once you're completing it, you recheck the cited reference are still in your text. Okay. So that's very important, because you need to change with your reference style as well, then add on the missing references in your text, and you have to modify your discussion. That means you need to add it on in your discussion, as well as clear what we call caption for your results. Okay, so that from my side. I think I'll pass to chairperson.
Yes, thank you, Dr. Gita. Yeah, now I would like to invite Dr. Chiu.
Thank you, Dr. Ong.
Yeah.
Zoe, I would like to go through the thesis comment based on the pages. So the pages I refer to is the paging number under the page, right? This one is 31. Can you see it? Now you're at page 31, right? At the bottom of the page is page 31, right? I refer to that page number, okay?
Big number. Okay.
Okay. First of all, I will comment on your abstract.
Sorry. Wait. Conclusion? 31.
Abstract. The abstract actually, normally, according to normal format, the abstract there is not necessary to put the aim or that subtitle in your abstract, the beginning of your thesis, the abstract at the top of your thesis. The very first page, no, after the table and all that, the first page, go top abstract. Before the intro abstract, go to the top of the thesis. Abstract.
Sorry.
The abstract of your, not abstract, abstract, the abstract of the thesis. Before
the abstract.
Yeah, the abstract, the chapter, the abstract before the chapter. We'll go chapter by chapter. Hopefully, your abstract. Yeah, I don't think you should put in all this background aim. The subtitle is not necessary there. Okay. Then the aim here, the put aim, right? Actually, the write-up is about problem statement and rationale of the study, not aim. Actually, the whole paragraph that you write under aim is actually the rationale of the study. So you should review that. Okay, that's not aim. This part is not aim. It's actually rationale of the study. It's not the objective of the study. Okay, so you can take away the aim methods, right? The subtitle, I don't think is necessary in abstract. Okay. Okay, so we go to chapter 1, 1.2. Yeah, okay, problem statement. I think the originality of the study, you can actually take away the 1.2 subtitle. Okay, maybe it's given in the format, the original format, from IPS or what, but it's not relevant to your study, right? It's not originality of the study, so you just take away. Okay, just put problem statement will do. Then if we go to page 5, number 5, 2.2. Yeah, here you have surviving. I think it's surviving, right? Not surviving, right? This, I think a spelling mistake is quite glaring. Expression of surviving, right?
Where is
The last sentence. Yeah. No. Page number 5. Go up. Yeah. The last sentence.
Oh,
Yeah. Okay. I think it's surviving, right? So all this glaring typo mistakes, you should avoid that. Okay. And also page number 6, 2.3.
6.3.
2.3.
Oh,
2.3. Page number 6, 2.3.
Oh, page. Oh, page.
Yeah, Constantine gene expression on cell proliferation. I think this subtitle is a bit misleading or not clear. So you should look at it. Constantine gene expression on cell proliferation. What do you mean by that? Actually, subtitle is very important, right? It gives the overall preview of what you are going to say after this, right? So if the subtitle is not clear or is not accurate, then it's misleading. People is going to read something. What is Constantine gene expression on cell proliferation?
It's actually because we use because I need to choose some genes to study, and so I see some article, and I ask from some people, and I get from this I get the three genes, KX7, PCN, and PGP. The KX7 and PCNA is proliferation gene, proliferation gene marker, and the PGP is drug resistance gene marker.
Yeah. I what you're trying. My comment is the subtitle itself. You should put in a better self-explanatory way, because this subtitle doesn't give any like reasonable explanation about what you're going to say. Constantine gene expression on cell proliferation doesn't tell much about it. Doesn't make sense, right? What is Constantine gene expression on cell proliferation? Constantine gene expression. Constantine is the Constantine effect on gene expression, right? And also cell proliferation. So it's something like that. So you just go and relook and modify your subtitle. I think it's a bit confusing. Okay.
So I need to do more specifically.
Yeah. Have to rework on this subtitle. And also we found that you mentioned somewhere, we found that, right, the third sentence, we found that Constantine supplementation resulted in a significant reduction, something like that, right?
Sorry. Sorry.
The third sentence, however, we found that Constantine supplementation resulted, right? That's actually the work is done by Verdowset, right? So we found that actually is when the reader will find that actually this is the previous work or something like that you have done before. Okay, when you put that, we found that it's misleading. Okay, you understand what I mean?
Sorry. Where is misleading? I know misleading, but
we found that. Who found that? Not you, right? This work is not done by you or your group before, right? So it's for Dowset 2014, right? So I mean, this kind of the way of how you present it is not accurate. Okay. So please review and revise all this kind of this way of presentation throughout the thesis. Okay. Then we go to page number 7. So we have to go to Page number 7. The first sentence. Page number 7, the first sentence. Yeah.
Sentence.
Yeah, inhibit tumor growth. So the last sentence is page number 6, right? So you see, inhibit tumor growth by regulating quercetin. You go up a bit. The whole sentence, right? I try to understand. Yeah, the pathway, right? The BCNA pathway, go up a bit. Just now, just page 6 and numbers. No, go up a bit. You just go up a bit. Yeah, stop. I want between page 6 and page number 7. The PCNA and PARP pathway, right? Go down. I want the whole sentence. PCNA and PARP. Yeah, stop here. Pathways may inhibit tumor growth by regulating quercetin. I think it should be the other way around. Like your quercetin will regulate the pathway, or the pathway will regulate the quercetin. Inhibit to go by regulating quercetin. I think again this sentence is also misleading, or right? How can the pathway inhibit the tumor growth by regulating quercetin? Okay, so please look into that.
Okay.
Right. After that, taken together, right? Taken together, another important cell proliferation marker. This also, I don't understand what they mean by taken together, another important cell proliferation marker. So this part also you have to. This is out of nowhere. You mentioned something taken together, another important cell proliferation marker. What do you mean by that? Okay. I think you mean something other than quercetin. There's another compound that you want to introduce, or something missing there. Okay.
Okay.
Page numbers 2.4. Yeah, 2.4 here, quercetin, right? You Q here, suddenly you put 225 micromolar of Q, right? What is Q? I assume it's quercetin, is it?
Yeah.
Yeah. Because it was not indicated before that Q is quercetin, so there should be some. If you want to use the short form, so you should indicate somewhere that Q is quercetin actually. Okay. Then RDB cell also, out of nowhere you have some RDB cell in this paragraph. So you should also mention what is RDB cell. Okay, all this abbreviation should be explained. Okay, you cannot just use abbreviation out of nowhere, then we don't understand what actually RDB cell is, what is Q, what is RDB cells. Okay, go check throughout the whole thesis on this kind of mistakes. Then you go to page 14, 3.5.1, page 14.
14.
Yeah, actually I have the same questions with Dr. Geeta. I actually lost when I read the thesis, especially when it comes to the results and discussion part. The way you presented results, you just put the raw data that you get from the after you process the data, right? You have the raw data, like the 9 graph just now. So actually you keep on mentioning there's only 8 cell line, but we see 9 graph there. Just now the 9 graph that Dr. Geeta mentioned, right? It's not clear. Actually, we cannot see anything, or we make any conclusion or understand from the way you presented. You just paste a 9 graph there. So all the results, I think, are the same. You put the data that you get, then you paste it on your thesis. Actually, the readers will need explanation on the results or any clarification, explanation, or any deduction that you get from the data. Without further explanation, we don't understand. You may understand because you are the one who process the data. We as reader, we don't understand what you're trying to tell us. We only see the graph which is not clear, then pasted there, then we actually cannot process what you're trying to tell us. Because from NCI 60, there is 60 cell line, right? Then you put 9 graph, 9 plot, right? Graph plot there. Then later on you say 8 cell lines. You keep on mentioning 8 cell lines, but 9 graph. So actually I'm a bit lost when you, if you see this 9 graph, right? Actually what Dr. Gita says was, actually we cannot see anything from this. Because NCI 60 is 60 cell line, right? How you deduce up to 9? Then actually, if you see your description there, you keep mentioning about 8 cell line, not 9, right? So what happened here? Because I also cannot see clearly what the graph is trying to tell me.
Because it's just an example to let people know the causing cytotoxicity for like this result. Yeah. So yeah, I should consider
Okay, so now mind go you please improve and enlarge the graph if possible. Then also the other for me, all this data that you put in is a bit like to us is like something like raw data that we need further explanation or further conclusion or deduction that you should put it in the storyline, like a story that tell us in a very nice flow what happened after this. Actually from here you proceed to next, what is the conclusion from this graph and this raw data, then only why you do so. You need a bit of explanation, not just like present your result in the way you only understand. Okay. Yeah, you should put more like explanation. You should explain, you should quote some references, what references, what is the reason, supporting data, supporting explanation, supporting scientific explanation why so and so. Then only you continue with the next, not like just put your raw data, then you put a figure, explanation, description under the figure, then you expect readers to understand. You have to communicate your result to us in a way that we can understand. And can you understand me, Zoe? Yeah, understand. This to us is just raw. To me, it's just raw data, without any processing. You need to process the data and tell us in a very nice story, in a nice flow that makes sense. Like why you go from this step to this step. Okay.
Okay.
Like okay, your figure 4.2, 4.3, right? It's like for example, figure 4.3. You highlight 6 boxes, right? We see 6 boxes, but under the description, you mentioned 3 cell lines were selected. Can you see it? Figure 4.3, for example. You highlighted 6, right? You draw 6 boxes.
Oh, okay. Sorry.
Yeah, but in the description, you say 3 cell lines were selected for subsequent investigation. So when I see 6 boxes, but you here in the description you say 3 cell lines were selected. Actually, this 3 cell lines were selected should be in your explanation, the result description discussion. Why from the 6 boxes or then go into 3? Why the 3 was selected? Based on what reason? You should tell us that. It's not you write it inside the description under the figure 4.3. You understand?
Yeah.
So I'm actually quite lost when I read the thesis. I don't know where you are going. Okay.
Okay.
So this kind of how presentation is throughout the whole thesis. That's why it's very difficult for us to understand what you are trying to tell us.
Let's just to explain the from the last screening, I choose 8 cell lines, and from the GFQ value, I choose the 5. I choose 5 cell lines from 8 cell lines because the GFQ is resistant, and we can say I that when I get presentation the
So there should be written explanation after each of the figures, not like figure after figures, without any story, any explanation. You understand what I mean?
Yeah, I know.
You have to process the figures, the data, then write a story on it. Tell us about what you have found out about this from this, what you deduce from this chart or table. What you find out, you can see right very clearly figure 4.2 followed by figure 4.3. In between there's nothing, right? And then you follow by table 4.1, nothing in between. You just post your data, pop the raw data. We actually don't know what this is because we are not the one doing the work, so we don't understand what you're trying to tell us. Okay? Okay, if you okay, Zoe, what do you want to say?
Let's just start the why I choose this because this cell line is sensitive and this 3 cell line is resistant and 1 cell line you know from here is 5 cell lines and 1 cell line is no information, so we can choose the one of the 3 cell lines to get the next study, and I choose one. Yeah, this is story.
Yeah, that if talking about that table 4.3, right? Table 4.1, sorry, table 4.1. You highlight you say the highlighted in blue indicate no detectable response, right?
4.1 this one.
Yeah, table 4.1.
Oh.
Highlighted in blue indicated no detectable response, right? To me, again, I find it I'm confused because it goes percentage, right? Because your title is including percentage growth inhibition. So from what I can see, the one highlighted in blue is 58.8%, 54.5% of inhibition, right?
Yeah. I mean,
why is among the highest? The 58.8 is the highest actually among the 8 cell lines. Why you say no detectable response to quercetin? I really cannot understand.
Yeah. This is the lowest. So you think it is sensitive, but this cell line is more resistant than this cell line. You know. You mean? Yeah, right. Hello?
Pardon? Yeah, I can hear you.
I mean, your question is the why I choose the lowest the value, the number, the lowest value number, the K566 cell line to you mean it?
My question is, I don't understand why you don't choose this blue, no detectable response. Why no detectable while the growth inhibition is 58.8% and 54.5, right? Why not detectable?
Oh,
No
why
detectable.
don't you choose this cell line to study? Yeah.
No, in the first place, it shows response, right? The response is 58.8% of inhibition, right? And 54.5 of inhibition, right? Number 4, number 5, highlighted in blue.
What sorry?
We are talking about table 4.1, right? You can see those highlighted in blue is number 4 and number 5, the SF539, right? And U251. You say cell lines highlighted in blue indicate no detectable response to quercetin. What response are you talking about? Inhibition, right? Growth inhibition.
This is not growth inhibition. This is Windows section results. And the the green one and the blue one is either no information or show the show the sensitive. So I don't choose this. Yeah, it's true. So I don't choose this because no information.
No, what information? No information. What information are you looking at? What do you mean by no information?
Some cell line in here and but miss some but I can't find some 就是some line some cell line here but some cell line missed here. We can't find the cell line from the GFH value. Yeah, the 8 cell line which is its cell line from the first screening, but we can't choose the 3 of the 8 cell lines from this picture, from this figure. Yeah, this is no information or this sensitive. All
What kind of information that you need, which is missing?
The cell line name. Cell line name don't have them.
Cell lines name don't.
Because it's not the consistent figure. Yeah.
Okay. So if you look at table 4.1, right, the title is including percentage growth inhibition, right? But inside what you presented is growth percentage. So are you trying to show us the data that you show us, the 55%, 39.1 is actually growth inhibition or growth percentage?
So where?
If you look at table 4.1, right, you said your title, you put including percentage growth inhibition, right? Then immediately in the table, you put growth percentage. They are the opposite, right? Growth inhibition and growth is the opposite, right?
This title?
Table 4.1,
Yeah, that's it.
Summary of cell line responses to quercetin treatment, including percentage growth inhibition, resistance, and sensitivity. So I would expect in the table you put growth inhibition percentage, right, instead of growth percentage. You understand? Because the title you want to project growth inhibition, right? The percentage of growth inhibition. But in the table itself, you put growth percentage and not growth inhibition percentage, right?
Yeah, right. Sorry.
So it should be growth percentage or growth inhibition percentage.
It's growth percentage. Yeah, this is growth percentage.
Percentage, not inhibition percentage.
Yeah.
Are you sure? Go inhibition or growth percentage?
I understand you. I understand what you mean. Yeah, this is growth percentage.
You should go and figure out actually
not
what you're
not
trying.
growth inhibition. Yeah.
Not growth inhibition.
Yeah. Growth
It's
percentage.
growth percentage.
Yeah.
Okay, sorry. And okay, another thing is about this table, right? Actually, the growth percentage and the cell line, you should separate them into two columns. One is cell line. So you put the cell line under the title cell line, then you have growth percentage. You understand?
Yeah.
The cell line and the growth percentage shouldn't be in one column. It should be in two columns. One is first column cell line, the name of all the cell lines. Do you understand? So it should be actually three columns. You should have three columns. The first column is to put the number 1, 2, 3 until 8. Then the second column, you should put cell line. Then you put your CCR, FCEM. Then the third column is growth inhibition percentage. Then you put the 55, 31, 39.1, the 56.4. You understand what I mean?
Okay, I know. Yeah, I should adjust this table.
Yeah, the table is not correctly
Yeah, I know.
presented. Okay. So you just go and figure out whether is actually growth inhibition or growth percentage. Okay.
Yeah.
Yeah, and you should also explain as you mentioned just now. What do you mean by no information? Why no information leads you to to make the decision to exclude them from your study? We need to understand why. Okay.
Yeah.
And why I still don't understand why you have the cell inhibition, but you said no detectable response to quercetin. You understand? Cell line highlighted in blue. We go back to the old question. Highlighted in blue, no detectable response. You have the results here, right? Why no detectable response to quercetin?
This is no detectable.
Huh? What do you mean by no detectable response to quercetin? The one in blue.
But in blue. You don't mean here?
Yeah, I mean table 4.1. You have cell lines highlighted in blue. You write under the box that cell lines highlighted in blue indicate no detectable response to quercetin. What do you mean by that? Because to us, it does inhibit the growth, right? Because you have the percentage 58.8, 54.5, right?
Wait a minute. The blue cell is no effect on the treatment. No effect is means sensitive in the GI50 values. Yeah, this is sensitive.
Where do you find that? How do you support that?
Here, the sensitive is right sensitive.
Okay. Okay. Then another one would be same thing lah. Later on you go to the as Dr. Gita questioned just now, K562, and then you did not proceed with HEP G2 and all that. You should explain it clearly. You should write in paragraph. You have write it down why. What is the reason why you exclude and proceed only with case 562 and not HEP G2? Okay.
For where?
Yeah. Okay. Then for your methodology, there are some sentences that write in future tense will be used and all that. So it should be all past tense, right? Your methodology you put in future tense will be used. All that should be corrected into past tense. You know that, right? Methodology already done. So you should use past tense in your write-up for methodology. Okay. And page 16, sorry, I go back to that. The test, page 16, 3.6. Sorry, because I had this question. Under 3.6, stats analysis. Yeah, the tests were done twice by a different person each time to ensure the result could be reproduced. What do you mean by that?
Because we need average and calculate the student t-test and the mean standard deviation. Yeah, we need this, so we need must do at least twice. But I need but I do but I done the trip have the
But why have to have
triplicate? Yeah.
What do you mean by a different person each time?
Actually, it's done by me, but in the future, I will do the further investigation and study and my supervisor will let another one to do this experiment. Yeah, and to make sure the data is.
You mean it can be reproducible, is it?
Yeah, but maybe not me reduce this, but anybody.
Okay. So we go to page 26, figure 4.6. Sorry, I go back to
Figure 5.6.
26, 4. Figure 4.6, right? Yeah, you have, go down a bit. Go down a bit. This is figure 4.6, right? You go down a bit again.
Okay.
No, actually those response curve of pure, all this is actually, talking about figure 4.6. This is a description under figure 4.6. Right?
Yeah, right.
Yeah. So it's not a written paragraph. It should be a description under figure 4.6. Okay.
Well,
And page 27, 4.4.
but I can't put here. I must have put in the figure.
No, it's under, yes, but here it appears
Ah.
like a written paragraph explanation, something like that. But actually is should be under figure 4.6, right?
Okay.
Okay, because it's your ABCD. It's a description of your figure 4.6. So it should go up a bit. I mean, it's under figure 4.6. It's not a separate entity, okay? Yeah, so okay, you go down here. Okay, stop here. So page 4.4, page 27. Yeah, go up.
Oh,
Yeah.
here. Oh,
27, page 27.
this is 27.
Yeah, go up.
Oh, go up. Okay.
Yeah, you see the sentence number 1, 2, 3, 4, right? For number 4, effects of Ki67. Is no significant effects of Ki67 in either controls. Actually, the word on and off is very, very important here because the effect is on Ki67, not off Ki67. Do you understand the difference between these two? On and off?
Yeah.
The effect of Ki67 and effect of Ki67 is totally different, right? One is subject, one is object, right? Do you understand the difference? If you put effects of Ki67 and effects on Ki67, they have totally different meaning, right? So I think you are not talking about effects of Ki67. You are talking about effects on Ki67.
Okay.
Okay, it's a small spelling, but actually it means totally different. It have totally different meaning. Okay, so please pay attention to this kind of mistakes. Okay, figure 4.7, page 28, the following page. Yeah, this one. Yeah, the jaw image. I have this question. Because I couldn't, like the third one, I couldn't see the ladder where you claim the base pair 281, 14, 147, 206, right? Why didn't you show the ladder?
Because it's some mistake. Unfortunately, I find them. So we can show this. Yeah, this is correct.
Okay, please include that, or else how can we say that no, this is, how can we identify the band and all that, because you don't see the you don't show the reference. Okay. Okay. When we go to, actually, we find that actually your result and discussion, right? You should actually, as I mentioned just now, the results, you should have the explanation and all that. You have to add in a lot of explanation and also a discussion. We don't see much. I don't see at all any comparison to previous literature review, previous work that other researchers have done. There's no mention, no code at all on this, like your comparison, what your how your data that you have you obtain compared to others' work. You don't see any discussion, any comparison from. So have you done any literature review on Constantine, Annenpeel, and all this?
Yeah, I see.
Actually, from in your result and discussion, I see only one reference. all the reference in your list all is on introduction before your result and discussion. Result discussion, only one references quoted. Why?
Because the discussion is too hard to write.
Too hard to write, but you have to write a proper, right? So after all the hard work, as Dr. Gita mentioned just now, you put in all the hard work to do the work. You have the result, but you don't present, don't explain, don't you should present and explain your work, compare your work to the previous, the existing literature review that you have. You have to make comparison. Then you have to cite the maybe possible scientific explanation to support your results, your findings. I think that is very much lacking in your thesis. Zavi, you should work on that. It would be a waste if you have worked so hard to get the results, but you didn't present it properly. Okay?
Yeah.
Because I think, no, only one reference throughout the whole discussion and result in discussion, which is, it doesn't make sense. Okay?
Okay.
Hope that you could add a lot more to it to make your thesis better. Then one question is that is very, very glaring is your findings, you say that actually this quercetin, the extract, onion extract, perform better than the pure quercetin, right? It's even inside your research questions, but there is no discussion. You just mentioned casually that the complex can be better. At the end of the conclusion, you mentioned the complex, the extract complex can be better from single pure quercetin, right? You just mentioned that, but you don't explain. You need something to support, further explanation to support why you conclude that. We cannot see just based on one sentence that you claim, which is your claim. We don't see any scientific merit to that. Why can your extract, not non-purified, right?
Yeah.
Can be better than a pure quercetin. It's not convincing. You should add in something to justify why you make that claim. Okay?
Okay.
Okay. Okay. I think questions. Okay. And then maybe my final question is, why do you, because of research question, why do you in the first place use NCI 60 and GEO?
First, because the idea is first to do some genes and do some comparison in the costing in the cell lines can treated with costing and reproductive report to the costing. This cell lines. So sorry. You can say my problem statement, and the SST is very earlier to detect. It can give me the many raw data. It can give me the direction, and so I can from the SST to get some cell lines to. I must need I must can find a cell line from the SST7 and to do the study. And because my ancestry results is get K562, this cell line, and this cell line is a resistant cell line. So so I need a cell line. I need a sensitive cell line to compare with the compare with the K562 cell line, and so I research from the GEO. GEO have many gene profiles, gene data. It can because it have raw data, so I can get the genes I like to study, and I found this article, and this article gave me the I found this article, and from this article get the raw data, get the three genes raw data, PGP, PCN, and KX7. I chose them. I also said again. I also said the PCN and KX7 is anti-proliferation gene. It's proliferation gene, and the PGP is a drug resistant gene. They are the very famous marker, and so we can get the next study.
Okay. Zeri, since you projected this one, right? Oh, this is your slides, huh? This one, yeah, this figure, right? Yeah, that we can see here, the log 2 fold change, right? In your thesis, right? Actually, sorry, I go back to figure 4.5. Actually, figure 4.5. Your thesis, right? A log 2. If you go to your thesis, sorry, I interrupt you. For figure 4.6, right? It's figure 4. Figure 4.5. Yeah. You go in description. Yeah, the last sentence is a log 2 FC bigger or equal to 1 is considered indicative of a statistically significant upregulation. So how do you explain the figure here? It's not significant, is it? Or because I couldn't see.
Despite the raw data is not significant, but we know the trajectory is the sensitive cell line, and we also know it have the I read where I say it have the upregulation and the downregulation. These three genes have upregulation and downregulation chained. So we can also to study these three genes, because these three genes is very famous in very famous in other articles or somewhere.
Okay, Zeri and Dr. Ong, I think that's all from me. Zeri, I think you need to actually explain, as I mentioned just now, elaborate more on your results and discussion. Okay. Thank you.
All right, thank you, Dr. Chiu.
Thank you, Doctor.
I think all the examiners have given their view and asked questions. I just make a brief summary on what they have, what I can conclude from here is the examiners agree that the experimental work was carried out. However, they find the thesis incomplete insufficiently referenced and weak in scientific explanation and communication. That's what I can conclude. And whether the examiners require major revision or require another presentation, that it of course depends on the examiner's verdict. So Dr. Gita and Dr. Chiu, please submit your report to our administration office as soon as possible, so that further actions will be taken. Okay, before I end the session, Dr. Koo, as the supervisor, do you have anything to say?
No. Thank you.
Okay, so Mr. Gao, you need to discuss with your supervisor once you receive the outcomes from the examiners, and then do the appropriate corrections or whatever the examiners ask. Please refer to the examiner's comments. All right. Okay. All right. So we end this session of Viva Voce here. Thank you, Dr. Gita. Thank you, Dr. Chiu. And thank you, Dr. Koo, for being here. And thank you, Mr. Kao, for being here to answer the questions and the presentation. All right. Thank you, everybody. Stop here.
Thank you. Thank you very much.
Okay, thank you, Dr. Ong. Thank you, Dr. Koo. Thank you.
So
Thank you, everyone.
I close the sharing.
Yeah, you can exit the meeting. Yes.
Okay, all right. I do it. Oh.
You just click the red button. Yes. Okay. So I don't know what you want to do. Dr. Chiu.
You still continue the recording or